All right, in this section, chapter 7, ratios in similar polygons. Hello, Mr. Rush. Figures that are similar. And this is the symbol for similar. It's the little squiggly line that's above the equal sign in the congruent symbol. So it's just that. All right, figures that are similar have the same shape. But not necessarily the same size. All right, so a definition here of similar polygons. It's in the middle of page 466. Two polygons are similar if corresponding angles are congruent and corresponding sides we'll say and corresponding side lengths are proportional. Two polygons are similar if corresponding angles are congruent and corresponding side lengths are proportional. And just write that proportional means same ratio. Proportional means same ratio. And we'll cover that a little bit more here in just a second. And one more definition. A similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. And let's put a comma right here. A similarity ratio is the ratio in simplest form similarity ratio is the ratio, in simplest form, of the lengths of the corresponding sides of similar polygons. So in this section, you're going to be asked to list corresponding congruent angles in two shapes. You're going to be asked to list corresponding sides. And then you're going to determine if two shapes are similar. And if they are, you're going to write a similarity ratio and a similarity statement. Okay? So, the first example on the bottom of page 466 asks you to identify the pairs of congruent angles and corresponding sides. And they give you two triangles. So, here's one of them. So this triangle on the left, SQR, with arc marks, two arc marks at angle Q, one arc mark at angle R. Triangle on the right, XYZ. With two arc marks on the Y and one arc mark on the Z. And here's your side lengths. C2X, 9, 6, 12. Alright, so the first part of the instructions ask you to identify pairs of congruent angles. So congruent angles. Let's start with angle S. What's angle S congruent to? Angle X, very good. And angle R in the triangle on the left is congruent to angle Z in the triangle on the right. And angle Q is congruent to angle Y. Second part of the directions ask you to list the corresponding sides. Now, when you're listing the corresponding sides, you're going to list them as a ratio. So, with the triangle on the left, I'm just going to start with side SR. Side SR goes from the unmarked angle to the angle with one arc mark. So the corresponding side in the triangle on the right would go that same direction. So it would go X to Z. Very good. And then I'm just going to go clockwise around the triangle on the left. So I'm going to call the next side RQ. And side RQ corresponds to side ZY. And finally, side QS. Side QS goes from two arc marks to no arc mark. So from 2 to none would be Y to X. Very good. See it? So now let's just go a little bit further here. Let's determine if these triangles are similar. In order for them to be similar, the angles have to be congruent. All right? So far the angles are all congruent. Agreed? The second thing that has to be true is that corresponding sides have to be proportional, which means they all have to have the same ratio. So under each of these ratios, let's write a ratio with numeric values in it. So this side SR is 13.5, isn't it? and side y or x to z is, how far is it from x to z? 9. Okay. R to q is 18, and z to y, that was 12. And q to s was 9, and y to x was 6. So now, if all of these ratios are the same, then the corresponding sides are called proportional, and the shapes would be similar. So just find out if these ratios are the same. Okay? Take 13.5 and divide it by 9. And let's see, 13.5 divided by 9 is 1.5, isn't it? So 1.5. And what's 18 divided by 12? Good, 1.5. And what's 9 divided by 6? 1.5. Are the corresponding sides proportional?
Yes.
Yes. They all have the same ratio. So what that means is the two triangles are similar. So the second example is going to ask you to write the similarity ratio and a similarity statement. So let's just do it with this problem that's up here, since it takes so long to get the triangles drawn and all the information down. So the similarity ratio. What did I say that the similarity ratio was on your other page of notes?
The ratio of the corresponding sides.
Ratio of the lengths of the corresponding sides in simplest form, right? So we're going to take this fraction and put it in simplest form. So what's 9/6 in simplest form?
2 thirds. 3 2.
3 2s, very good. All right, and aren't all of these fractions going to have the same ratio? Because they're all equal to each other. So your similarity ratio of these two triangles is 3 to 2. And now we're gonna write a similarity ratio. I'm sorry, a similarity statement. But we're gonna do it up here so we can look at the triangles when we're writing the statement. So similarity statement.
You can only do this if they're similar, right?
Correct. Now, if the ratios weren't all the same, then you would stop and you would just say that the polygons are not similar. Now, the similarity statement. If the polygons are similar, you're going to be asked to write the similarity ratio and then the similarity statement. There are 3 correct similarity statements for these two triangles. You can always name the first shape, or when you name the first shape, you can use any order of the vertices. The order doesn't matter in the first shape. Okay, so let's call the first triangle, let's call it QRS. All right, triangle QRS is similar to triangle. Now, this is where the order of your vertices is extremely important. It determines the correctness of your statement. So look at the order of this first statement. It went QRS. And another way of saying QRS is 2 arc marks to 1 arc mark to no arc marks. So if you go from 2 to 1 to none, you got to go from 2. So this triangle on the right would be Y, to 1 arc mark, which would be Z, to no arc marks, which would be X. That order is extremely important. Another similarity statement for both of these triangles that would be true. You can just rearrange the vertices. Maybe the triangle on the left, we're going to call it RSQ. if you named it RSQ, then the triangle on the right would have to be named Z to X to Y. Very good. Does everybody understand that? Okay? So in your assignment today, you're going to be asked to list congruent angles. We did that right here. List corresponding sides, which we did right here. Then you'll be asked to determine if the triangles are similar, which means they would all have to have the ratio of corresponding sides, same ratio, or the lengths of the corresponding sides have to be proportional. If they all have the same proportion or same ratio, then you're going to list the similarity ratio and write a similarity statement. Any questions? Short section, but a bunch of information, yes.
Do we have to write all the possible similarity ratios?
No, and I just showed you the different types of similarity statements so that if you wrote this one, okay, but then you checked your answer and this was back there, you would know that you're not necessarily wrong.
That's just another possible.
It's just another version. If the shapes have four sides, okay? If the shapes have four sides, there's four vertices, which means there's four correct similarity statements, right? Because you could order the four letters four different ways. So if the shape's got five sides, same thing. Now there's five correct versions. You just have to understand there's not only one answer when you're writing the similarity statements, but the order of the vertices is extremely important. All right, your assignment for today is on page 469. One through 5. And 7 through 10. And be sure to check Edline for homework.